Um, we've heard a lot about what happens when policies and proper authentication aren't well thought out. And now we're going to dive a little bit into the mindset of attackers. And we're going to discuss how oftentimes highly skilled attackers tend to avoid reinventing the wheel, right? And they tend to keep a low profile by avoiding leaving a trail of binaries and files behind them. Our following speakers argue that this is why living off the land is still one of the preferred approaches to security professionals. Next up, we will listen to Tiberiu, who is a data scientist and machine learning engineer, and alongside him, we welcome Andrei, a technical lead and security intelligence and engineering at Adobe. They will tell us all about why it's hard to detect instances when an attacker is living off the land. But not all hope is lost, because they will also follow up with an in-depth look at an approach they created to make such detections. Gentlemen, you have the virtual stage.
Hello, thank you. So, hello everybody. Thank you very much for joining this talk. We are actually really excited to be here. My name is Andrei Cotaie, and together with my awesome colleague, Tiberiu Boros, we're going to have today a short discussion on a project we recently open sourced and that we're actually really fond of. So with no further introduction, a supervised machine learning living off the land classifier. I know, it sounds fancy. Okay, so a couple of words about us. We are the security intelligence team at Adobe. We are a part of Adobe Security Coordination Center. The ACC actually handles monitoring, alerting, and incident response. So in other words, the reactive part of the security in the house. The purpose of the security intelligence team is to do data science research in the security field. So we mostly focus on reactive security as the ACC, and that basically means identifying threats that cannot be detected via conventional ways. In other words, we use the logs and the security data we collect from Adobe assets, and we try to find anomalies and of course bad stuff. Now, we really like sharing our work, even outside of Adobe, and we have quite a couple of open source projects, presentation, and blogs, and we're actually going to touch base on some of those later in this talk. Okay, so for a short intro, like what's living off the land? So easily put, living off the land means doing your job with what you have at your disposal. But let's be honest here, this is not the 13th, 14th centuries anymore, right? Those are not the Middle Ages. And the truth is, what we have at our disposal is more than enough. Now, living off the land is not a brand new concept. Living off the land attacks, persistence, lateral movement, however you want to call them, have been recorded and reported for a while, since the beginning of the century at least. All the big kids are doing it, attackers, APT groups, pen tester, purple tips, and so on. Now, what's really interesting about those type of attacks is the fact the footprint they leave. It's really, really reduced. And the reason is that, why is that? Because basically you don't have new binaries, you're trying to blend in, and you already have everything you need at your disposal there. Now, the truth is between a security professional, if you have Bash, Python, PowerShell, Cursor, Util, Viget, or whatever you want there, what more do you actually need on that box? Plus, in the last cases I looked like Netcat, it became a default admin tool on most of Linux installs there. So living off the land refers to attack scenarios where multiple segments, parts of the attack itself, are being delivered with what you already have on the compromised box, on the box you are on, right? So no external malicious or especially crafted tools or malware for that matter. Okay, and again, the whole magic is that what you need is already there. And there are some people who did an awesome job documenting this, right? And I'm sure that you're actually really, really familiar with those two links that are there. They're basically living off the land binaries with example documented, and a lot of examples do a lot of stuff, right? So, for example, you need to download something and you do not know what to use. Well, go to the link and you're going to find quite a couple of ways to do your job. You need to abuse a legit binary to execute some code. Again, go to the link and you're going to find a couple of ways of doing that. You want to escape a text editor and become root or whatever user is there. Again, go to the link and you'll find really nice examples. Now, of course, things aren't always so straightforward, right? But the fact that what you need is already there, it's a great starting point. A clear advantage of using on-prem stuff like scripting your way in, is the fact that you blend in. You are one with the environment. You are the administrator there, right? And you can behave like one. Maybe you're good enough to put also a couple of security patches in place, right? Like stop other attackers from compromising your already compromised box. And I'm sure all of you actually heard a story about those kind of scenarios. Anyway, let's get a little bit serious. So what we want to talk today about. Me, as a security expert, I handle quite a couple of incidents and security investigations in my time. So almost every time I learn something new, something that evaded some of the measures in place, something which on its own would have bypassed my security mindset, right? Also, we at Adobe work with petabytes of data. So that's definitely more than what a couple of dozen of people are able to parse. And the question is, how can I make sure that what I'm detecting is everything that's happening and that nothing is actually bypassing my security stack? And the honest answer is I cannot, but I can give it my best try. I can always think outside of the box. And actually, that's what this project is about, thinking outside of the box. Okay, so what we've done, we took thousands of examples of malicious commands. We did some voodoo magic around them, and then we built a classifier whose entire purpose is to tell me if a piece of string looks like it might be a threat and why. And as you can see really fast, our tool is actually pretty simple to use. You pass it a command, and it's basically going to generate some text, some meta information, and well, the classifier is going to classify the data, right? Pretty straightforward. Regarding the environments we're targeting, so the Living of the Lamp project actually comes with two models, a Linux one and a Windows one. Currently, the performance of the Windows one doesn't make it qualify for production ready, and we estimate we're actually going to have a stable model somewhere next release, the end of this year. But the Linux one is actually really similar with what we're using in our infrastructure in production, targeting Adobe data. So let us actually talk really fast about the magic behind the project. Now, we basically can split the project in three components: data set, feature extraction, and machine learning. So what I'm going to tackle today is actually the feature extraction, and Tiberi is going to speak more about the data set and the machine learning part. And I previously said that the magic behind this project are actually the tags. It's all about the tags. The training data is critical, but the magic is in the tags. And my classifier is going to be as good as my tags are, and of course, as my data set is. So what kind of tags do I actually generate? Well, anything that actually crosses my mind there. So let's not speak about tags and commands. Let's actually speak about myself. What can I say about myself? I can say I'm a male, somewhere in my early mid-30s. I wear glasses. I'm starting to get a little bald here and things like that. So more or less things like that I want to say about my commands as well. So what kind of tags I generate? Well, I care about binaries that are executed. I care about the paths from where they are executed. I care if I saw that kind of string in the past. I care with who it communicates, if it communicates with public, with internal IPs, with local hosts. I care about keywords. I especially care about those little dashes that appear there in the commands, in the parameters. And I especially care about patterns. And good patterns are actually game changers in this project. Okay, so what I'm going to do, I'm going to go through all those special tags we're generating and go a little deep inside them and try to get you to understand what's actually happening there. So what do I actually mean by binary tags? Well, the concept is actually pretty simple. I'm checking if a particular command binary executable, netcat, let's say, NC, right? If that is a part of the command itself. So I basically made a list of the most interesting binaries from an operational security perspective. And every time I analyze a command, I check if that command is actually part of the string I'm investigating. If they are, we basically add a tag to that event just saying command and the command itself. So historically, when we actually started to build this project, those were the first feature we built our initial classifier on. For our example today, I actually took a standard Python interactive shell command, and I'm pretty sure everybody's familiar with it. It's a really common one, right? What we did, we basically split it into words. And then we check if that command Python tree is actually present in the list of the keywords list that was generated there. And that's what we did. Now the code is pretty. The logic on the code on the slide is the same as the code we have in the project, but the code in the project is a little more complex. But again, it's basically doing the same thing. Now, the same goes for keywords. Basically, keywords represent a list of interesting keywords parameters we actually identified during our research phase. So for everything we thought it might have a security implication, we created a list and we do the same check. And as you can see, it's pretty straightforward. Now, it doesn't mean that this solution is not prone to false positives. You can have binaries with different names, or you can have some keywords parameters that have different impact and different commands. If you guys are Linux fellows, you know that's actually true. But this is not a problem because we generate so many other tags. Tags that might have a negative impact on the classification itself can be held by the other tags that were generated. So again, the magic, it's in the tags. Now, all the static information we're presenting on the feature extraction part are actually in a Python file called constants.py. So there is half of the magic of this project. So basically the entire security subject matter expert security knowledge that we apply to this project and we made the supervised implementation is basically in that file. You can modify the constants.py file at any time. You can add stuff, remove stuff, repair stuff, and so on. And those tags are going to reflect directly in your results. Now, it might get ignored by the machine learning component until the model is going to be retrained. Okay, we're doing the same thing for path, right? We made a list of interesting paths for different Linux processes, binaries, interesting directories, and we check if those paths are present in the command line itself. Straightforward, similar to the previous one. Okay, so this is useful because it can highlight interesting activities like sensitive files, binaries running from wrong locations, interesting activities, and so on. Again, all those elements used to generate tags are present in the constant.py file, and the list can be updated on the fly. So the development of this project was some sort of a modular approach. Like we initially started with interesting binaries and keywords. We built a classifier, we tested the classifier, and we were disappointed. So next we added the interesting paths, and we did the same again, like built a classifier, tested the classifier. It was slightly better, but still disappointing. And then we added networking information. So basically what the networking component does is to search if there is an IP information present in the command itself, right? And mark it as public, private, local hosted, whatever type it is. Now, for you guys who are actually using endpoints to collect your data, you know that sometimes the IP itself information is not going to be present in the command, especially if you have a domain there, right? But there is a high chance that you have another field in the event generator that contains that IP information. So what we do, we concatenate our command with IP information, and then we apply the model. Now, imagine you have two reverse SSH tunnels in your infrastructure. One is going towards a public IP, one is going towards a private IP. So which one would you investigate first? Which one most likely is not an operational activity, right? So basically we'll try to enhance the project with the same security mindset that we apply in our work by adding all kinds of different tags to it. Now, the networking part had actually a significant impact in the accuracy of the classifier, but this was still not good enough. Sorry, something went slightly wrong here. Okay, cool. So the last component actually who had a major impact in our classifier was the regex part, right? So the question was, what other feature we can extract? And of course, the simple answer was regex. So after tagging data with commands, keywords, paths, network information, we still didn't reach a production-ready accuracy. So the question was what we can do better. And again, the answer was regex. Now, historically, I've been working on content creation, alerts, notables, rules development, and I know that regex can generate usually two main problems. It can be too strict and it can ignore interesting stuff, or it can be too broad, and that actually might create a large number of false positives. So what we actually did? Well, we went with the second approach with broad regexes and the chance of lots of false positive, but we created many regexes, hundreds of regexes. So the idea was to catch as many features as possible, just as a PTI spawn netcat and map netcat flags and map flags and whatever flags you want there, right? in the end, take all the data we generated, put it through a classifier, and let the classifier decide what's malicious or not, like what tags and what pair of tags is going to turn red. So even if we have a lot of potentially low confidence tags because of the regex, and again, we have many of them, the regex tags added more and more context, and the machine learning component behaved better and better. Now, from a technical perspective, we encounter one major problem. The feature extraction component became really slow. So we switched from regex to regex 2, PR2 from Google implementation, and from series execution, like one regex at a time, to parallel execution, where I actually have sets of regexes in parallel with pipes between them, and try to get the groups from there. And this actually reduced the computational time almost 8 times. We had another bug last week, which identified if we have actually multiple regexes which overlap and they are in the same line, the same group, they're going to suppress one another. So we did last week a rebalance of the regex data set. And again, that actually increased the overall confidence of the model. Now, the same goes for the regex. All the information is present in the constants.py file, and anyone can add regexes, but in order for them to provide context for the machine learning model, you need to retrain the model. So some of you might need this project just for the tagging system, and Tiberiu is going to do a great POC about that, right? So you're going to need it for dataset creation, analysis, RPAs implementation, or whatever you actually want. And any modification you're going to do to the constant.py file, it's going to reflect right away in your results. But the model might ignore new tags or might have a different results depending on how we actually enhance the tags, right? Because the mentality behind the tags has changed and the model might behave differently right now. So for the classification part itself, you need to retrain the model. Okay, so now I'm actually going to pass it to Tiberiu, who's going to go a little deeper in the data set and model part of this project. Tiberiu, take it away.
In here, we are going to start talking about the data set and the machine learning model that we are using in our approach. And I'm going to start by saying that probably the most important thing about our machine learning approach is that we are using supervised algorithms. Now, these algorithms actually require label training data, and the major problem is that a large-scale living of the land data set is really hard to find. So we struggle with this, and in the end, we actually had to build our own data set almost from scratch in order to create our system. Now, the living of the land classifier is open source, and we do provide the system with pre-trained models, but we are unable to share the data set. So if you want to create a custom model, this is no problem because you can actually do the same steps that we did. And it's not that hard. It just requires some minor work and a little bit of effort, but it's going to be worth it because you would be building a model that is, suitable for your own data. So how we got the data set? We started by collecting some living of the land examples from the sources that Andrei mentioned earlier in the presentation, and we got somewhere around 1,600 examples of malicious living of the land commands. Now we filtered them out. We removed something, command lines that were a little bit ambiguous, so we wouldn't confuse the model. And then we added to this data set another 7.9 million examples of benign command lines, which were actually extracted from logging our infrastructure for a couple of weeks, removing duplicates, and filtering out some of the stuff that wasn't really relevant. We got a really skewed data set. The ratio between negative examples and positive examples is somewhere around 0.02%. But that's actually okay, because this way we hope to reduce the number of false positive during runtime for our model. You can imagine that if you go with balanced data set and you get a false positive rate of 2%, and you have an infrastructure and you are logging 100,000 command lines per hour, you'd actually be generating 2,000 false positives every hour, which somebody would have to go over, filter out, and establish if that's good or bad. So instead, by doing so, we actually got a model that is not that paranoid, and it's really reliable. So when it says that something is malicious, it's worth investigating. We actually have it into production, and we only generate like 4 to 6 detections per day. Some of them actually being the results of different penetration tests which are carried out by our team, so they are not all false positives. So to talk a little bit about the model, we have 7.9 million examples. We, after going to the tagging strategy and adding the tags, we actually added 7.5 million total tags to the data set. And you can imagine that some of the command lines actually have multiple labels assigned to them, while others don't have any tags assigned to them because they don't present anything interesting from the security point of view. And the number of unique tags is 500. Now this is really good because we have a lot of training data, and only, the feature space is somewhere around 500, which is actually really good in reducing data sparsity and preventing the classifier from overfitting the training data, and generalizing better on previously unseen data. So if we go to the next slide, we are going to talk a little bit about the algorithms that we tested. So we did something which is called Fivefold Validation. This means that we took the training data, we split it into 5 folds that actually try to preserve the same distribution between the negative and positive examples. And we trained the classifier 5 times using every combination of 4 folds. And then with each time we tested on the 5th fold, which was kept aside. So we rotated through them, and we computed the mean, the standard deviation, and the training time for a single fold for 3 classifiers: a random forest, an SVM, and a logistic regressor. Now, best results we got using the random forest and the SVM, 0.95%. There's a smaller standard deviation for the random forest than for the SVM, which is also good. And also it's a much smaller training time. It's only 18 minutes compared to 3.5 hours. Now there are 2 important aspects about the classifier. So the random forest was the only classifier which was able to work with a sparse feature set, which meant that we didn't have to convert the input features into a dense matrix, and this greatly reduced the memory footprint required to train the model. And the SVM, the results reported for the SVM are reported after we actually applied something called the Intel patch, which made it possible to train the SVM from scikit-learn on multiple threads at the same time. And we got to 3.5 hours per fold. Otherwise, we virtually weren't able to train it because it took a prohibitively amount of time to do a single fold. On the next slide, we are going to talk about one more tag that Andrei left out. So we have to mention that while we do rely on the classifier to establish if a new example is good or bad, we felt that, it won't be good to miss things that we know for sure that are bad. They resemble something that's inside our data set, and it has been labeled malicious. So we created a special tag for this. The tag is called looks like non-lol. And what it does, it overrides the decision of the classifier for examples that were labeled as good, but they resemble something that is bad in our data set. So in order to generate the tag, we test every command. We test a new command against all the commands inside our data set, and we do a type of fuzzy comparison, so it's not exact string matching. And there are 2 obvious options, or the obvious option would be to use Levenshtein distance to measure this, but this is Levenshtein is really complex. It has an n-squared complexity. It runs really slow, and there are many commands that we have to test against. So instead of doing that, we use a different score here, a different score function, which is called blue scoring. Blue scoring has been previously used in machine translation to establish if a computer-generated sentence resembles the sentences that are translated by humans. And it's very fast. And what it does is it returns a score of 0 if two examples have nothing in common, two sentences or two command lines in our case, and it returns a score of 1 if they are identical, and everything in between depending on how different they are. So after playing with the examples in our data set a little bit, we actually set a threshold of 0.7. So when we do the test, if a new command line resembles something in our malicious data set with a score higher than 0.7, we assign this tag and we override the decision of the classifier, directly setting the command line as being living of the land or bad. On the next slide, we'll be talking about how you can install LOL. So there are two simple options. The first one is the easy pip installation one. You just do a pip install lolc, and it's going to install the package as well as train along with pre-trained models on your platform. It can be a virtual environment, or it can be the global Python installation. It doesn't matter. The second option, you can clone the repository, just create a virtual environment, activate it, and install the requirements, and you have a working installation of Living of the Land. Now, the advantage of doing this is that by doing so, you'll be able to create your own model if you want to, not to rely on the default ones that we are providing with the system. You can build your own data set and train the classifier on it. On the next slide, we'll be talking about how we can use the Living of the Land classifier. So it's pretty easy. We have an API for Python. You just have to import the main class and the platform type for the API from the API. The next step is to create a new instance where you can specify if you are targeting Linux or Windows binaries, command lines. As Andrei said, the Windows model is not really stable. It's not production ready, but the Linux one works pretty well. However, we do provide both models, so you can, you have a fully functional Living of the Land classifier in your system. Next, you need to get your data, and then you can apply LOL on the commands. Now, you can apply it on a single command, or you can apply it on a list of commands. If you select a list of commands, it's going to do multiprocessing, and it's going to optimize the way they are labeled and put to the classifier. So it's going to be much faster. If you have a lot of command lines, just use the batch version and it will do everything for you. Regardless of what you do, you are going to get two things. You are going to get the classification and the tags. The tags are the ones that Andrei presented earlier, so you have access to them. You can use it to do your own analytics or do some searches with them, whatever you want to do. And the classification is almost binary. So we have the good and bad labels, which are pretty obvious. And you also have the neutral label, which we are going to talk about it during the demo. So let me just share my screen for a moment. Okay. Can you see my screen? Okay, perfect. So what I did was create a virtual environment, just install the Jupyter Notebook because it's much easier to do the show and tell on it. And I'm going to use the pip package installation. I'm going to run this command over here. It's going to go pretty fast because it's already cached on my system. I'm going to create a new instance that handles Linux command lines. And after this, we're actually going to run the Living of the Land classifier on multiple commands, one at a time, so we can easily read the results. I'm going to do this really fast. Okay, so what happened? It took the command line, it tried to describe it with tags. So you see that it assigned the IP loopback here because you have the loopback IP, of course. It also saw a public IP here. It contains SSH. It has the -R keyword. And there's also, this is the result of a regular expression that was triggered, which targets SSH with -R altogether, right? It did this for all the commands. So this one has sudo which install SSH-d, and it also looks like a non-Living of the Land command because it resembles something in our data set. This one is pretty interesting. So you're going to see that this apt-get install Python 3 was labeled as neutral. So this is because we actually assigned less than 5 tags on this command line. And when this happens, the classifier doesn't have enough tags to rely on to make a good decision. So we just remove all the tags and enable the example as being neutral. Now, this is normal if you have small command lines and common command lines that you are using on a daily basis. But if you have a really long string and it gets labeled as neutral, it might indicate that you are dealing with something obfuscated maybe. And that's why we weren't able to extract any text from it. And you might want to look into this. We do have another project that targets obfuscation, but we'll not be presenting that here. So most of them have the looks like non-lol tag, which means that the classifier, the decision of the classifier was overwritten by this flag. But if we scroll down, we are also going to have a lot of commands that were labeled as being bad, but the classifier has never seen them before. So they don't resemble anything in our training set. But again, they were labeled pretty good. Two more things about this utility. So if you feel lucky, you can actually change the constants that define the keywords and the command lines and the paths that we are targeting. So there's a file which is called constants.py. It's in the main distribution of the application. You can see here the list of Linux commands, the interesting Linux paths, the keywords that we are looking for. And there's also this really large variable here with regular expression. I'm going to get back to this one. On the bottom of the source, you're going to see the same for Windows commands. Now, those regular expressions, you cannot edit them in place. It's impossible. Believe me, I tried, but we do have another utility here. Well, you can actually set, or introduce one regular expression at a time, set the label for it, and after you define all of them, it's going to pack, pack all the regular expressions and make them run in parallel, so they would be really fast. I guess this is my POC. I'm gonna give back control to Andrei, so we can speak about how you can actually use the living of the land classifier. Okay, this is not, you are not sharing the right screen, I guess. So I'm going to start speaking anyway. So you can use it as a standalone tool. You can integrate it with an EDR solution or go over some CM logs and label command lines as being good or bad. You can use the text for analytics, as I said before, but the way we use it sometimes it's within a project, a larger project, which is called One-Stop Anomaly Shop, OSAS. This is a previously open source project that, while living of the land actually looks at every command line on its own without any context, what OSAS does, it is able to take into account multiple features that describe the context in which that command line was run. So it looks at process names, users, environment variables, and many other things. On the next slide, we have the architecture for OSAS. It's pretty straightforward. So it just requires a data source, which can be a CSV or a JSON data source, or it can come from Splunk, Elasticsearch, anything you want. And there's a processing pipeline. And this processing pipeline is fully configurable. And it kind of applies the same strategy as the living of the land classifier. And it tries to describe every event with labels. And it's going to handle numeric labels based on the mean and standard deviation of a value. So it might add, so if say you input CPU usage or memory usage, you might get labels such as extremely large CPU usage or normal CPU usage or previously unseen CPU usage. It does the same thing for multinomial fields, which are text fields that don't take an infinite number of values, such as usernames or process names, and you're going to get labels such as rare user, rare process, and so on. And you can also apply the living of the land. It can combine any types of fields between them. So you might say you want to combine the parent process with the command line, or the parent process with the username, and it's going to say rare parent process user combination. You get this label as well. So it also, you have the option to apply the living of the land classifier on any text field. Obviously, you want to run it for command lines, not for plain text or source code or anything else, because it's not going to work as expected. When you do that, you are actually going to get the binary decision of the classifier in the tags that OSS is generating, as well as all the other tags that are used to describe the process by the living of the land classifier. And finally, OSS is going to do anomaly detection. It has the option to do unsupervised anomaly detection with using different algorithms. So we support autoencoder, local outlier factor, statistical engram, and frequent item set mining. And you also have the option to do supervised anomaly detection using any supervised classifier which is present in scikit-learn. You can configure it in the pipeline, but you are going to provide you are going to be forced to provide training data to it, which means that you need to add another label, another column to your data set, which is going to say if an example is good or bad. And you can train the classifier this way. Well, I guess that's it. We thank you everybody for joining us.
Thank you so much for your demo. It was really exciting to watch it live. And I love the name you gave to some of those tags. I'm also stealing your regex joke. I hope you don't mind. I mean, you open source the software, might as well open source the joke. I'm a bit curious. Have you ever tested your software against any honeypots or against any real commands coming from actual attacks?
Yes, so we have used it also for internal Adobe data. We have a flavor of this model that's targeting inside Adobe data, and we're using Adobe incident data in it. And we have detected a couple of tests from penetration testers from our purple team, and also something regarding internal incidents. I cannot go more in detail than that, but yeah.
Awesome. I was wondering, and you sort of also segued into my other question, is there anything interesting that you've left out of your presentation, not knowing whether you'd have enough time to delve into it?
Yeah, of course, I guess the Windows model. So the Windows model, we actually did have a lot of work on it. We have a lot of text we generated. The problem is the data set we're working on, it's not big enough to have a stable model. So I know most likely someday we'll come back again, having also the Windows model up and running. But for the time being, if anybody actually needs to tag Windows data with this platform, it should do the trick.
Have you considered doing a sort of call for participation in the open source community? Since you open source the tool, it would be a great time to also say, folks, let's gather some data together, especially if you're using this, especially if you're using it, you know, against real commands coming from places where commands usually come from.
Well, this is one of the main reasons we're actually doing this talk, because we do want to get some traction and get people working with us. So if you guys try the model and it fails, because things fail in life, as I mentioned in my previous slides, just send us the command, like a change format. You don't have to have the actual indicators in it, and we'll try to make it to fit the model, or we can work together to do that. And that's actually, we're sharing the GitHub link there, because we really want you guys to check it out. And if you like it, please give us a star.
I think we should use this as one of the mottos for the conference. Things failed, but gather the data.
Yeah, that's life.
Thank you very much, Andrei. Thank you for the presentation and the awesome demo. And I really hope you get a lot of traction on your GitHub. I'm a huge cheerleader for the open source community and for collaboration that spans not countries, but even continents. And if you get commands in languages which the project doesn't know about yet, that's going to be an even better challenge to tackle.
Sure thing.
Thank you.
Thank you.
Thank you.